Welcome to topic 2 of our polynomial unit. We are going to use this time to write equations from the zeros. And yesterday we talked about zeros, also roots, also x-intercepts. So I want to remind you that whenever you factored, in functions and trig and in algebra 2, you were given like a factor, like the factor is x minus 7, and then I would give you the factor and you would give me the 0. So you would say, all right, x minus 7 equals 0, and I would add 7 to both sides, and I would say 7 is the 0. And so a lot of us looked at this and they were like, oh, I just changed the sign and I've got the 0. That's great until something like this, 3x minus 4 equals 0. And I can't just flip the sign and say it's positive 4. I actually have to solve. So x equals 4 thirds. Okay, so that would be my 0 here. So hopefully that was a reminder to you when you were factoring. So then I'm going to work backwards. I'm going to say I give you the 0. So right here it's just a number, but like if we look up here at what I just did, notice that I say like x equals 2. So if I work backwards, like this way, to get the factor, I would want this to be equal to 0. So I would subtract 2 from both sides. I kind of did that backwards, sorry. And then I would have x minus 2 equals 0. So right here, x minus 2 then is my factor. Okay, so again, people will think like, oh, this is super easy. If 2 is my 0, all I have to do is switch the sign. Again, that works here on this left side, but on the right side it doesn't work. If I give you some sort of fractional 0, you have to kind of work backwards just like we did here. So I'm going to say x equals 2 thirds. And my first step then is going to be to multiply both sides by 3. Okay, because that gets rid of my denominator, and then I'm going to subtract 2 because I'm trying to get this to equal 0. This is my factor. 3x minus 2 is my factor. Okay, so that was just a little reminder of things that we did in Algebra 2 and in functions and trig. So how does it relate to this? I'm going to give you more than one 0. You get more than one 0 this time. You're going to give me not only the factors, but you're going to give me the polynomial. So we're going to have to remember how to FOIL, because this is my favorite F word, FOIL. Also factor. Factor is another one of my favorite F words. FOIL is first, outside, inside, last. Some of you would use the box method where you were putting these in boxes. So whatever makes most sense to you. And I should be able to try this 2 ways. So I've got these 2 zeros here. These are my zeros. So if I give the zeros, first step is to find the factors. So I have a 0 at x equals 4 and x equals negative 3. So x minus 4 will be the factor here, and x plus 3 will be the factor here. Okay? And then I'm going to multiply these together to find my polynomial. Okay? So I'm going to take my 2 factors and find my polynomial. Now I hope you noticed that I had 2 zeros. So I should have an x squared function based on the fact that I got 2 zeros. So I'm going to have x minus 4 and multiply x plus 3. FOIL or box method. So for FOIL, first x squared outside plus 3x inside minus 4x last minus 12, and combine like terms. If you prefer the box method, you'll do something similar. So I'm not talking my way through this. You'll get the same answer, hopefully. Okay, this is my polynomial of least degree. Okay, what does that mean, least degree? Well, there's probably an x to the 4th or an x to the 6th or an x to the 100th equation that has these two as zeros, but I don't want that. I want the smallest, and the smallest I can be is x squared because I have two zeros. So we talked, though, yesterday I talked in the video about how many times it crosses the x-axis and that fundamental theorem of algebra that says they have to have, like, if it's x to the 5th, it has 5 roots, and I don't know if they're real or imaginary, but I know it has 5. Well, right here, I'm going to give you, look at this here. I have one real 0, and these two are imaginary or complex zeros, okay? So I know this is going to be an x cubed function. It has one real, because 2 is a real number, and it has two imaginary, okay? And I just want to point out that there's a word called conjugate, which means that negative 4i and 4i come as a pair. They are called conjugates, and they come together all the time. They, if I have a negative 4i, I always have a positive 4i. So those are complex conjugates, I should call them. Okay, and I put this reminder here in the star. The square root of negative 1 equals I. And that's going to be important to us. So I'm going to find the roots again. I'm sorry, yep, the factors again. So this is going to give me an x minus 2 factor, x minus 4i factor, and this one will give me an x plus 4i factor. So step 1 in these is going to be multiply the two imaginary together first. Okay, so always start with your imaginary factors. So when I multiply these together and FOIL them, I'm going to get x squared minus 4ix plus 4ix. And here's where everyone gets tripped up. So I'm at 4 times 4 is 16, and I times I is I squared. Okay, so 4i is negative 16i squared. The goal here, you should have no i's left. Okay, that's your goal here. I hope you see that this here, these cancel out. I have minus 4ix plus 4x, they are gone. So now I'm left with this. And I reminded you over here that the square root of negative 1 is I. So if I square these both, I squared is the same as negative 1. So I've got this, x squared minus 16, and I squared is negative 1. When these multiply together, negative 16 and negative 1, I get this, okay? Notice there are no i's left. I'm all done with the i's. So that is why we need to take care of that step first. And now I can go back to this and multiply this through. Remember, I need an x cubed. So that was just the first step. Eek, misvote. Okay, so I'm going to multiply these two together. This is still just like FOILing, okay? I'm going to go x times x squared, x cubed. Outside, 16x. Inside, minus 2x squared. And last, minus 32. And then I need to just write this in standard form, combine like terms, all those things that are pretty easy to do. This is my polynomial of least terms, of least degree, with the roots at 2, positive 4i, and negative 4i. And so if I drew a picture of this one, I honestly have no idea what it looks like. I just know that it crosses once. It has a positive leading coefficient, so it's going to point up to the right and down to the left. And the other two zeros are imaginary. All right, that's it for topic